Hello, welcome back. This is going to be an alternate episode for 33, which is extremely long. I condensed it down as much as I could, but those 2 hours and 45 minutes are all filled with actual non-dead-end activities that led me to a solution to harvest time. So I will have to show off my graphs. They're very good, and I found a way to improve them further, so that's going to be cool. Anyway, yeah, so harvest time. It's hard to believe, but our first full-size kelp beds are ready for harvesting and processing. Derek worked on the mechanics. I'm designing the control system. Soon Ocean's Bounty will something, and there's my victory message. Okay, create a working design for this product. So, right, yeah, I already read the spec because I had a good solution for the wrong spec. Got a whole lot of things here. This was the one that was shown in the full episode 33, and this is an improvement upon that because there was one little optimization that I knew I could make. I'm going to try something different here. I'm going to attempt to go from a blank grid to the design that I put on there, partially from memory, but I will check in with the reference when I need to copy some code over. But anyway, so let's at least try and mirror sort of the process I went through. So very first thing I did was I knew I needed a better storage API than what I had on my first attempt at this. And I just kind of carved out a space on the board for it. The wiring ended up looking something like this. Oops, not that. So these microcontrollers together do storage-related tasks that take a lot of work to do. This is where my coordinates of where I need to harvest are stored. So the main thing I was changing compared to the good solution for wrong spec thing was instead of having a queue with two address pointers that chase each other and just act as a ring buffer here, I was just going to leave... I'm going to delete from the middle of the queue and shuffle everything back up so that the queue tail is always at the very beginning and the queue head just moves in and out as I harvest things. I need some more wiring here. You need A1 and probably D1. Well, it looks like I can wire through here if I want. Do I want? I think so. That's probably what my wiring looks like in the full solution. Okay, and this is your communication with the outside world. The radio here, yeah, so I realized the radio can be moved around wherever. So I just kind of carved out the left side of this space because this is very much, you know, a dead end. This is... You talk to this to talk to storage, and this was about as compact as I could get it. I look at this big wire and wonder if there's a better way to do it, but there just isn't because I'm using a lot of this middle space. And it turned out I actually had a lot of space to spare in the board. This layout over here is still kind of obnoxious. It annoys me that it has to be the way that it does, but it does have to be that way just because of this layout, because this little cutout, I can't move this one more to the right. I want to say harvest, like, snuck through here and went out there or something. That feels about right. Okay, so anyway, there was an MC6000 here, which talked to the radio RX. Something is not right. I think you move left, because I need to connect to the RX and not the P0. Okay, and oh yeah, something's wrong here with the address line, definitely right. Okay, so this actually connected like that instead of that. Something's not right with the data line either. Okay, so what's wrong with my wiring? Let's look at finished here. Okay, so the wiring went around there, that connected to... Okay, yeah, that is right. Really? Why does it all look so wrong? Okay, no, that's how it is. Right, okay, so I snip that. And this actually just connects here. That's how it is. Okay, so address line is accessible to this. Data line is accessible to this. That's the D1 line. So right, the one who talks to the radio has wire access directly to the A1 and D1 of my storage. So what you're going to do is when you receive a radio message, you directly store the the coordinates that come in. So let me copy some code over. I'm going to skip the first little bit. Yeah, I'm just going to copy from here to here to go through this procedure. So yeah, you won't see the whole thing, but this is the abbreviated version. X3 is connected to nothing. Right, so the layout of this lets me get a wire out of here so I can talk to more things. Is this the layout I want for this? I think so. Yeah, so that harvest wire goes over here. So these are the motor controllers, and those are pretty familiar, so I can just copy this exact code out of here. Already seen how this works. Pin not connected, we know. That goes over like that. I'm actually going to go ahead and just change this to X1 right now, while it's convenient to do so, because I have a plan for X0 here. That's going to be an improvement upon what I had done in the full run of this. So anyway, we know how this code works. Went over it in E32 or whatever it was. Anyway, so move X2 AC. X2 is radio RX. See if it's a negative 999. If it's not, then send that on to the motor controller controller. You'll of course be doing SLX and X1, etc. X0 is how you communicate with this. And there was something else in between. Right, okay, there was an extra dude here who I thought I needed as an I/O expander for routing to this and to the, was it the address line? I think so. This layout is not identical to what I used, but it's close enough. Move X2 to X1. Yeah, okay, so report coordinates there when it needs them. And there's an additional task here. So right, in this storage I am putting pairs of coordinates. So you know, the 7, 4, and I'll get a 7 there and a 4 here. And the A1 pointer is kept in... It's not kept at the start. No, so I read whatever the A1 pointer is. This points at the head of the queue. So the place where the head of the queue is stored, you know, how many, like if it's at 0 at this point. When I get 7, 4, it'll be at 3. When I get the 9, 4 and haven't harvested the 7, 4, it'll be at 5. When I delete 1, it goes back by 2. So that's how I know how many things there are in the queue to harvest. So I read the current address of this into my ACK register. I reset that pointer, the X0, the A1 here, to 0. I read the first 2, so the oldest position, the one the motors are going toward, and send that out X3 to the motor controller controller. So this will of course forward them onto that. And then I reset the address pointer back to what it was. So that sits where the queue head is. And then I sleep. There's a little more in this controller you might have noticed in the finished product, but I'll talk about that when I get there. Okay, so motor controllers are there. Motor controller controller needs a bunch of stuff. Okay, so let me just copy this whole thing and we'll see what it does. That's fine. So, things this needs to know about. It needs to forward destination coordinates onto the motor controllers. Those tell it their current position. Oh yeah, there's some code in here that does stuff that doesn't make sense yet. This is a little different from the motor controllers that were used in my partial solution for the wrong spec, but don't worry about it yet. Alright, so X1, right, the 2 coordinates come in from there, read from the beginning of this, and they are moved on to X2, which is motor controller 1 for X, and X3, which is motor controller 2 for Y. And yeah, these just talk to the simple pins and stuff. Okay, then I move -1 out to X0. This is an I/O expander because this needs to talk to both... it needs to know where the queue head is to know whether there's anything to harvest or not. And it also needs to talk to this. Right, the role of the storage system ended up being... Initially, let's see, where would I have put... Yeah, originally the tasks that this was going to do were add new coordinates, get oldest coordinate, find match, delete index. It ended up only being able to do these, and they ended up being a single operation. So let's copy some code in there. So I'll go back to finished, copy this. My copy-paste is working right now. Sometimes it just refuses to go between designs here. Just gives me like 2 numbers with a comma in between for no reason I understand. And let's get the I/O expander while I'm there. Just because that actually makes sense right now. Okay, so this was, yeah, see that, I got that. Okay, so I'm gonna go finished, open, select all, copy, escape, escape, click, click, highlight, paste. And that time it gets it. Why is it so weird about the copy buffer? I don't know. So anyway, right, this one wants to be able to talk to both the address line of this, because it wants to read where the queue head is, and it needs to tell this to do a storage task. And it only had 1 pin to spare, so I used this I/O expander to be able to... yeah, right, so wait, so x2, this line to that, using a TCP, so I either send it -1 if I want to retrieve the current queue head, so if it's that, I just read from x1, the A1 line of this, and send it there. Or it's +1, which is to forward messages to this and reply. So 2 parameters come from here to here, 1 parameter comes back, then 1 more comes back here. So that's a little bit of a complicated task. So anyway, oldest coordinates come in here, get forwarded to the motor controllers. I read the queue head position into DAT, so I know how many, what index of coordinates I'm harvesting. And I just sort of save that away for later. So I guess don't think about that just yet. It'll make sense soon. So I tell this, I want to communicate with my storage controller. I send the I/O expander the motor controller's current position. So this is position X, coming in the X2 line. This is position Y, coming in the X3 line. And those go here. And they just get forwarded on from X2 to X0. And that's where this gets its ACK and DAT. So that's invoking a find match command. So since I need to harvest any crop that I walk over, I need to search through the entire queue for a match every time the motor moves. So that's what's doing that, and it asks for the result to be stored in ACK here. Okay, so anyway, right, so that forwards those on here. This stores 1 in each register because it's going to need to be comparing those multiple times. So my X coordinate is in ACK, my Y coordinate is in DAT, and I'm able to do this loop without any counting because the 100p14 counts for me. And I have a line to the address of that. It would be more pleasing to do this. Sure. So in the loop, okay, so I move 0 to X2. That's A0. A0 is only ever used by this controller specifically, not accessible to the outside world. Both D1 and D0 are used by this. I'll get to what this does in a moment. It helps this with its task. Right, basically because I need to delete from the middle of the queue. This searches, this deletes. I'm surprised I was able to fit delete into this small space, but I was. It does manage to do that. So anyway, take ACK, X1, right, okay, so move 0, so set A0 to 0, test if my X coordinate equals what I read from the data line. So D0, I read this, data pointer moves here, X coordinate gets compared to ACK. If that comparison fails, I still need to throw away another value so that my pointer will stay in sync because I'm doing 2 comparisons here. But if it succeeds, I do a second comparison of the Y coordinate, current position of U, against the Y coordinate stored here. So that's how I match whether your current position is harvestable. If both of those succeed, what do? I read the address. Basically, the address after where the match was. I used to just return like a 1 from here, say yes there was a match so you can harvest, but I needed to do some extra operations on exactly where that match was. That doesn't have to do with delete. I also move... Oh, no I don't. I just leave the A0 pointer where it is, and this does some operations that assume that position here. Let me actually copy one more thing from here. Or we can just read it here. So preconditions for delete. A0 is at deletion index +2. So yeah, since the match, let's say the match was here in these two. Let's say it's 1, 2, 3, 4, and these are parked at 3 and 4. So I matched 3, 4. There's also a 5, 6 in here. What needs to happen is this 5 needs to overwrite the 3, and the 6 needs to overwrite the 2, and the Q head needs to be moved back by 2 indexes. So basically the A0 pointer goes to the index of the 5, because that's immediately after where the match was. And then I need the A1 pointer to be 2 back, because I'm going to be copying from one side of this to the other. So that 5, I read it from D1, and I write it to D0. So the 5 comes out of here and goes here. And then I just continue for as long as I need to. So anyway, those are the preconditions that allow delete to be done in this little amount of space. So anyway, yeah, so the A0 is established, and I also communicate it to the outside world. Then I do some work in here that needs to be done. So yeah, let's do the bookkeeping first. X3 is... Oh, actually, I can't do the bookkeeping yet, because that comes from the outside world again. I'm going to tell it to this. Ah, right. I used to do the arithmetic on it here, like I'd move x2 to AC, move, is it sub 2? Sub 2 from it. Right, because the preconditions include... The message that wakes you up is address of A0 -2, so that's where the A1 ends up going. Because you don't have access to A1. I didn't have enough pins for that. Other than the instruction count, that's why this has to be split across 2 controllers, because I need both addresses and both data lines, but also communication to the outside world. So anyway, I used to do the arithmetic here, but it fit better here, so when I communicate the address just past my match, that's both a success value, the failure value is 999, by the way, and also is something that this does further processing on. So this does it. Can I run this program at this point? No, something's wrong. I know why. Okay, I'm missing one component. This can't actually quite execute just yet. So, I move... Right, it was the part of this that I didn't copy over. I'll get to it. I move this here for you to do some stuff with that I'll talk about in a bit, but also you sub 2 and write it back. So that's arithmetic. The sub 2'd thing goes to x0 and wakes it up. And then you jump to wait. If no match is found, you see if you've wrapped all the way back around, because x2 is A0. You search through the entire thing, and if you haven't, you jump to loop. And if I land here, then neither of these jumps went off. I reached the end of the queue without finding a match. So I report the failure, which is 999. There was a reason I chose that value. I'll talk about eventually. And then... Right, the arithmetic comes back, because I only need this value if I found a match, but you're going to write it regardless. You're going to write 997, because you sub 2, unconditionally. So I discard that 997 to clear the IO line. Anyway, so I've awoken this deletion controller with the address that A1 should be set to. So you move x1 to x2, which is the A1 line. read the value in the storage at D0. I'm going to change something here. This will actually allow the thing to execute. Kinda. I'll have to change these back because there was a problem with this design. Right, so you read it to ACK, you copy it to the other place. So basically, like, if this is 1, 2, 3, 4, 5, 6, 0, 0, 0, 0, 0, 0, and I am overwriting 2, 3 with 5, 6 and moving the queue head to here, what needs to happen is 5 gets copied over 2. Or sorry, no, 1, 2. 5 gets copied over 3. I was saying the wrong thing earlier. 6 gets copied over 4. And a terminating value, because I am using these zeros as terminating values, you might spot the problem with that already if you're keenly observing, gets written to where the 5 used to be, the original copy. So I copy enough that I pull in an extra value from beyond the end of my queue that acts as a terminator. The 6 gets left over here. It's stale. It's in the Y coordinate though, and I can detect on odd numbered rows, if we're counting by ones, that I've hit a terminator. So it doesn't matter that every other row past here gets stale data in it. It just does not matter at all. And it would be too much work to clear it out. So anyway, right. So I see if I've read a 0 only after I've actually moved it there because I want to write it unconditionally. If I've read a 0 and therefore I'm done deleting, then I go here. Otherwise, I keep looping until I've reached the end. Then what's this? Right. Because I read a 0, my marker for current queue head end, I need to do some arithmetic on A1 to keep it pointing exactly at 1 past the end of the current queue of commands, because this just wants to write them directly as they come in over the radio. So I read the value of A1 to ACK sub 1 and move it back in, because since I read a 0 for the terminator, I need to move the pointer back by 1. Alright, so that's all well and good. Can I run this? Yes, I can. Okay. So I can run this now, and there was one kind of last-minute problem I ran into. Was it that early? Yeah, it would have been. Okay, right. So when I get here, things go a little bit wrong. Why is that? Right, so right on this tick, something doesn't go right. I'm supposed to harvest, I'm supposed to move my motor there, so obviously I'm harvesting this one that I'm next to. So you're supposed to do motor Y equals 0, motor X equals 50, yeah, that's what it says, and harvest equals 100. But it doesn't do that. So if I look in my data here, yeah, so this is what stale stuff looks like. So 03, 04, those are nothings, at least the way I had this implemented. I have 1-4 queued up, 1-4. There's no kelp there, so isn't that weird? 5-1, 5-1. There's no kelp there either. Isn't that weird? 3-0, 3-0. Also no kelp there. So something's obviously gone very wrong with my storage. If you hadn't spotted it already, 0 is valid data here. 0 can never have kelp in it. That's where the machine parks. That was another part of the spec I actually failed to read. The harvester will never receive a command to harvest its starting location. But I was using 0 for my marker value to say, oh, there are no more commands here, so you can just stop. So what I had to fit in at the last minute, I think this was an MC4000X for a long time, and it was actually up here, and so was the radio. I had to do this big, complicated relaying out task to kind of flip stuff vertically here. But I did eventually do it, because I had this super compact, nice little thing like that, where everything just fit real snugly into this spot up here, and I loved it. But I had to break it for this, but it turned out better. Anyway, so I needed to add different Sentinel values. So -1 is my Sentinel value, and I need an init command to first write -1s to everything in there. So I do that at the start here. Oh, right, and these also initialize with 50. Mm-hmm. So this gets a whole bunch of -1s before it goes anywhere. And I couldn't use the at prefix for these because I had to actually do a loop with a conditional. I can't have at and minus in a line at the same time, just like you can't have both minus and plus. That's just not a thing you can do. So I just had to do another jump here to skip my init commands subsequently from that. I also got to change this back to a -1, and these care whether they are at their origin or not. What did the motor controller look like in here? X0 dat, TCP dat ac, a little different. Move x1 dat, right hand tech dat -1, and then it does the TCP. Okay, so I also had a problem at some point. Here, let's try this. Yeah, so if I just delete these lines now, this won't get much of anywhere, because it's trying to move to -1, -1 first, so it wants to go left and down, and that doesn't make any sense because there's nothing there. So what these lines do is if I'm sent a -1 as my coordinate, that means it's come in from that data, because it gets sent the first two regardless of whether there's anything in the queue or not. If you get that, you just want to hold at your current position. So AC is where the current position is stored in these, and it just overwrites its target position with its current position in that case. I had a bug in there where I was doing this instead, but that failed when there was a test case that harvested kelp at a location that, when the queue ran out, but this was not at 0, 0. So we'll see that in test case, is it 3? No, it's 10. So you go all the way to test run 10, this is almost working by the way, before you run into a case where all the kelp gets harvested. Like if I breakpoint here, and reset, simulate fast. I'll put that back to slow because it's fun to see this thing run around at the first 3 test cases. So yeah, it harvested all the kelp. The queue is empty. It gets a -1, but since I was hard coding 0 there instead of its current position, this wants to move toward -1. Or sorry, no, that's not what it does. Anyway, something was wrong with that, and this was the fix. So this will run, and this will complete the solution as in, right, yeah, so 33 yuan, 84 lines of code, that looks right. The power usage is going to be what it is. There's my breakpoint, on breakpoint. Okay, well, whatever, I guess I did it. It kind of has to work hard to run all those test cases. And this is what the graphs look like. I am way below on power usage somehow. So I guess I was very efficient with that. A little above on lines of code, very average on cost. So now the graphs of... Right, anyway, so yeah, victory message. Congratulating Dr. Sumura, Ocean's Bounty Program. Right, so we solved not world hunger, but local hunger here on the island. And it's great. So everybody's very proud of themselves, and Lisa gets pulled into something for Enzo. Right, Derek, DePaul at Mech.Avalon, he does the robotics. So anyway, yeah, rebuilt and finished have identical graphs. But I got this thing here called improved, which is unverified, but a thing that bothered me, this should look almost... Yeah, okay, no, that looks a little different. This should look the same, basically. This moved up a tile for no reason. Yeah, really no reason. Yeah, it's more comfortable to have it down one, like I did in rebuilt. But anyway, so this little I/O controller bothered me because its only, I/O expander, its only purpose, it barely had a purpose. If X0 could communicate directly with the storage controller here, then there'd be no need for message forwarding. And if you could just get the address of the queue head some other way than asking this to read it out of here, then that'd be great. Like this one has access to this A1 line here. Right, did I ever go over that? No, I didn't. Okay, so a detail I didn't manage to explain here was that this sends back the address of where the match was found. And let's see, what does that stop it from doing? It stops it from doing things like saying, okay, I found a match with a 0, 0. You need to harvest at 0, 0. It will find that match and send back 0, I think, as its address. Or 2, actually, because it sends back the address of the next thing after the match. But this checks to see what the actual queue head is, so the A1 pointer will be sitting here at 0. And makes sure that what comes back from here is actually within the known bounds of the queue. That's how it does that. It does it with this comparison. TGT ACK DAT. ACK is the... Right, yeah, the reason it goes into register is because I need to do arithmetic on it and move it back there. Yeah, so ACK is the return value of this. DAT is the queue head that was read out of this, initially communicated here. Right there. Anyway, yeah, so there's like instruction inefficiencies here because I have to tell this what I want to do, which a line I want to communicate on. And like this entire thing looked like it could go away if I could just squeeze one more line into here to communicate the value of A1 to this, so it wouldn't have to ask that. I tried really hard to do that and I actually couldn't find a way to do it the way I phrased it, but I found another way. So there wasn't a spare I/O line to be found anywhere in here. Yeah, I need my X0 for talking to that. There wasn't a spare instruction to be found anywhere in here. But check it out. There's a spare I/O line and instruction all the way over here in this motor controller. So over here in Improved, I didn't show this in the full episode 33, so you get a bonus here if you watch this version. I added one more line. So yeah, that's why I connected this to X1 in Rebuilt. Because I wanted X0 to come all the way out here and connect to the A1 line of this. Because you, at a known time, can totally read that line and send it back over a line that already is connected to this. I/O expander goes away completely, my cost goes down from 33 to 30 yuan, lines of code go down from 84 to 76. And power usage is going to go down too, because there's just a bunch of instructions here and there that don't need to execute. The difference is I don't have the move -1 to this, I don't have the move 1 to it, so X2, motor controller X, comes back with, where's my move X0? Move X0, X1, after you've done all your other logic. So just read A1, the queue head address, and write it out to that line that's already connected. So that goes into DAT, then I can just talk directly on X0 to this thing without any forwarding, and everything works. So I haven't run this to completion yet. My graphs already looked really good, and they're going to look even better with this, because there are fewer lines, there won't be as much power, and the cost is down. So I improved every axis. I'm wondering how visible those will be. Man, that looks good. If I could delete one more line of code, I think this bar would move over here because it's 0, 12.5, 25, 37.5, 50. So then that means this tick right here is 75, and I'm at 76. So I'm actually right here at 75. I don't know what it does right on the boundary. Maybe I'd still be up here. But if I got to 74, I'd be at this peak. But who cares if I'm above this peak when I'm this far below? Yeah, okay, so this moved left by 1 visible tick, and this moved left by 1 visible tick. Man, okay, so it took me a long time, but I totally nailed that puzzle. And I did manage to do the one big improvement that I knew I could do. So I am extremely proud of this solution. It just looks good every way you look at it. Yeah, the lines are a little high, but a little high on the graph I care least about is extremely worth the two I do care about. So yeah, like, this process worked. It took a long time, but I was successful in making a very efficient, very working solution to this monster of a puzzle. Anyway, cool. So yeah, very proud of that. And I will see you next time for new stuff.